Welcome back to Mr. Vaughn's classroom. Before we get started, I'd like to ask you to please hit the subscribe button so you can receive notifications anytime I add a new video. And if you wouldn't mind giving this video a thumbs up, I would greatly appreciate it. Now today, we are in Unit 4 on functions. This is going to be Lesson 5, Using Function Notation to Describe Rules, Part 2. The learning goal today is to graph and find the values of some functions. And we have 3 learning targets today. So as we're working through the practice problems, these are the 3 things you want to keep in the front of your mind. And if you have any questions about them at the end of the lesson, please feel free to ask for clarification, whether that's in person or by leaving a comment below. Learning target number 1 says I can use technology to graph a function given in function notation and use the graph to find the values of the function. Learning target number 2, I know different ways to find the value of a function and to solve equations written in function notation. And learning target number 3, I know what makes a function a linear function. Our first glossary term is dependent variable. This is a variable representing the output of a function. We call it the dependent variable because the number that you're going to calculate for the dependent variable depends on what value is put in for the input. Therefore, it's the dependent variable. Next, we have function. A function takes inputs from one set and assigns them to outputs from another set, assigning exactly one output to each input. And this is the vitally important thing. In order for something to be considered a function, every unique input is only allowed to have exactly one output. If you're in a situation where you can put one number in for the input and get multiple numbers for the output, then that is not a function. Next, we have function notation. Function notation is a way of writing the outputs of a function that you have given a name to. If the function is named f and x is an input, then f of x denotes the corresponding output. When we write these, first we have the name, then we take the input and we put it in parentheses, and it can either stay like that, and you can think of f of x being your y, or you might actually know what the output is, and you could add equals and then whatever your output is. So we can write it both ways. Next, we have independent variable, a variable representing the input of a function. So the key here is that you are able to change this value. You're picking this value that's going to go as the input, generally as the x value, and then you're going to use this independent variable to calculate your output. Next, we have linear function. A linear function is a function that has a constant rate of change. Another way to say this is that it grows by equal differences over equal intervals. For example, f of x equals 4x minus 3 defines a linear function. Anytime x increases by 1, f of x increases by 4. So in a linear function, you are continually growing by this same amount or decreasing by this same amount because you end up adding by this same amount or subtracting by this same amount every time. And what happens is when you turn this into a graph, you end up with a straight line. And that's where the name comes from. Now we can start the practice problems for Lesson 5. The cell phone plan from Company C costs $10 per month plus $15 per gigabyte for data used. The plan from Company C costs $80 per month with unlimited data. Rule C gives the monthly cost in dollars of using G gigabytes of data on Company C's plan. Rule D gives the monthly cost in dollars of using G gigabytes of data on Company D's plan. Number 1, write a sentence describing the meaning of the statement C of 2 equals 40. So I want you to remember a statement. Anytime we see these words, gives, the next thing it lists is going to be the output. Using, the next thing it lists is going to be the input. We also need to remember that with function notation, we have name, then in parentheses, we have the input, and it equals the output. Now using this information, C is going to be the name, 2 is going to be the input, and we see that the input is gigabytes of data, and 40 is going to be the output, which we see is monthly cost in dollars. So for number 1, Company C charges $40 for 2 gigabytes of data. Now we can look at number 2. Which is less, C of 4 or D of 4? What does this mean for the 2 phone plans? So, if I want to compare these, then Company C of G equals, they charge $10 per month plus 15 per gigabyte. So we're going to say 15G plus 10. If I want C of 4, then that's 15 times 4 plus 10. 15 times 4 is 60. And 60 plus 10 is 70. If I want company D, then D of G equals $80 per month with unlimited data. So it equals 80. That means D of 4 equals 80. So to answer the question, which is less, C of 4 is less than D of 4 because 70 is less than 80. What does this mean for the two phone plans? If someone uses 4 gigabytes of data, company C is cheaper for them. That's what it would mean. Number 3. Which is less, C of 5 or D of 5? Explain how we know. So what we're going to do on this one, we already know the equation to find out company C. So we can say C of 5 equals 15 times 5 plus 10. 15 times 5 is 75. And 75 plus 10 is 85. D of 5 equals 80. Therefore, D of 5 is less than C of 5 because 80 is less than 85. Number 4. For what number, G, is C of G equal to 130? What we want to do is we want to substitute 130 into that equation for C of G that we had calculated. So we're going to say 130 equals 15G plus 10. Now I need to solve for G. So the first thing I'm going to get rid of is this plus 10. The opposite of plus 10 is minus 10, and I'm going to do it to both sides to keep it equal. 130 minus 10 is 120 equals 15g. Now I need to get rid of that 15. The opposite of 15 times g is dividing by 15. And I'm going to do it to both sides to keep it equal. And 120 divided by 15 is going to be 8. So for the answer, what number g is c of g equal to 130? That number is 8. For number 5, they want us to draw the graph of each function. So the first function I'm going to do is actually company D. This is the easiest. Notice that company D, d of g, always equals 80. It never changes. And 80 is our output, so that's our y value. So we want to go up to where y is 80, and we're just going to draw a horizontal line along 80. And I'm just going to label this as d of g. Now, when we are trying to do c of g, that value is going to change. So when we have no gigabytes, 15 times 0 would be 0, plus 10, so we can put a point here. Now we can go over to 1. 15 times 1 is 15, plus 10 is 25. So we can come up and put a point at 25. Now, every time we increase g by 1, we're going to add another 15, because it's going to be 15 times 1, 15 times 2, 15 times 3. So all we need to do is keep adding these. And now we can draw the line that connects them. And we will label the purple graph c of g. So now what we can see here is that anything below 4.5 gigabytes, and function c would be cheaper. Anything over 4.5 gigabytes and d of g would be cheaper. And right about 4.5 gigabytes is where they cross, so that's where they're costing the same amount. If you have any questions about how to do any of the parts of this multi-step problem, please ask for clarification, whether that's in my classroom or by dropping a comment and asking for help, and I'll be glad to get you any clarification that you need. For our next practice problem, function g is represented by the graph. So the parabola, or the big U-shaped curved line there, is the graph representing function g. Every single point on that line is making g true. They are asking for what input value or values is g of x equal to 4. So remember that 4 is our output. So this 4 is the y value. What they're asking is where what would x need to be in order for y to be 4? So what you can do is I'll use a highlighter, and I'm going to highlight this line where y equals 4. And what you want to do is you want to find the points where that's true. So we have a point right here, and we have another point right here. Then you're going to look down, and you're going to see what the y values are at those points. And you can see you have -2 and you have +2. So that means the correct answer is B. And one thing I want you to notice is that you can have a function where an output goes to two different inputs, and that is still a function. What you wouldn't be able to have is one input having two outputs. So in this case, we can see that the one input of -2 has the one answer of +4. The one input of 2 has the one output of 4. So this is still a function, and this is how you would answer a question where they give you the output and they're asking you for the inputs. If you have any questions about this, again, please ask for clarification in class or in the comment section. Our last practice problem for this lesson, function p gives the perimeter of an equilateral triangle of side length s. It is represented by the equation p of s equals 3s. Number 1, what does p of s equal 60 mean in this situation? So remember, I had told you, anytime you see function gives, the very next thing is the output. And in function notation, you have name, then in parentheses, you have the input, and it equals the output. So that means if the output is 60 and the output is the perimeter, P of S equals 60 means the perimeter of the equilateral triangle is 60. Now, number 2 wants us to actually find the value of s that makes P of s equals 60 true. So for this one, if P of s equals 3s and P of s equals 60, then 3s equals 60. I need to get rid of this 3. The opposite of 3 times s is division. So we're going to divide both sides by 3 to keep it equal. And we find out that s equals 20. So now we know that when the side length of the equilateral triangle is 20, then the perimeter of the equilateral triangle is 60. If you have any questions about any of the practice problems we did in today's lesson, please ask for clarification in class or in the comment section here. Again, if you haven't already, I ask that you subscribe to my channel so that you get notifications every time I upload these videos. And if you found this helpful, please give the video a thumbs up. And I look forward to seeing you in the next lesson.